Good morning, children. Welcome to your chemistry online class. So, I hope all of you understood what was our previous class. So, in today's class, we are going to discuss about how to write electronic configuration, mainly the subshell configuration. So, we'll do that. So, what do you mean by electronic configuration? It is the arrangement of electrons it is the arrangement of electrons around the nucleus. So we know that electrons are revolving around the nucleus in shells. Each shells contain subshells. So it is the distribution of electrons in the orbitals of an atom. So we can see there are certain energy levels. Inside these energy levels, electrons are revolving. So we know that the energy levels as described by the principal quantum number, that is n. So the revolving of the electron denoted mainly by four quantum numbers, that is principal quantum number, azimuthal quantum number, spin quantum number, and magnetic quantum number. I hope all of you studied this. So here you can see the different energy levels, that is it is denoted by n, that is principal quantum number. It's denoted by the letters 1, 2, 3, 4, 5, 6, and the number of electrons can accommodate in each shell is given by the formula 2n square. Here suppose, for example, here if n is equal to 1, we'll get 2 into 1 square, that is 2. If it is 3, we can write that 2 into 2 square, then 4 into 8. It will goes like that. You know this. And we know that in a energy level there are different subshells. So in a energy level there are subshells. In a shell there are subshell. For example, in a school there are different classes, different standards. In a different standards there are different divisions. For example, if the 9th standard is there, there are A, B, C divisions are there. Similarly, if we check a energy level, in that we can see different subshells, that is S, P, D, F. Here S means sharp, P means principal, D means diffuse, F means fundamental. Okay, then how can we write this configuration? Here you can see, here first we have to write 1s, 2s, 3s, 4s, 5s, 6s, 7s. Then we know that in principal quantum number, if n is equal to 1, this is given by the orbit azimuthal quantum number. So for writing azimuthal quantum number, there is an equation, that is n minus 1. So for example, if n is equal to 1, that 1 minus 1, 0, that will be the azimuthal quantum number there. It's 0 denoting S subshell. 0 denoting S subshell. For example, if n equal to 2, 2 minus 1, which gives 1, that is denoting the P subshell. So SPDF, like that it will be there. And we have to write like this. First step, we have to write the 1s, then 2s, 3s, 4s, 5s, 6s, etc. Then 2s, we know that in the second energy level, 2 subshells will come, S and P. 0 and 1 value will come, n minus 1. The 1 value is there and the previous value also we have to write. So 0, 1 will come. For n equal to 3, it will 0, 1, 2. So SPD. For third energy level, there will be SPD subshells will be there. If it is 4, then n minus 1 equal to 3. So we'll get SPDF. Like that it will. So nothing to worry, we can write like this. So we have to write in order. We'll get like 1s, 2s, 3s, 4s, 5s, like that you can write. And here from 2s you can write there is also P. So 2p, 3p, 4p, 5p. You can write 6p, 7p. And in 3 subshell only the third subshell is coming. So you can write 3D, 4D, 5D, 6D, like in this order you can write. How we can write the configuration? Here you can see that this arrow is denoting this. Here I can, you can see that first we have to draw diagonally. So like this, first subshell electron should be filled in order to the increasing order of energy level. You have studied this by the several laws are there in that we have to fill the electrons in the lowest energy level first. So which is the lowest one is here? 1s. So here is only 1s. This arrow is denoting that. Here you can see 1s only. So how it will go? Here you can see, if you can see here, you can see that from 1s, then 2s. Then from this 2s, like this arrow is moving. Then you can see that 2p, 3s, 2p, 3s. You can see that 2p, 3s. Then this 3s, from this back side it should go 3s, 3p, 4s. Then similarly 4s, 4s, 3d, 4p, 5s. Here you can see that. Similarly it will goes like that. Okay, then how can we write the configuration here? So let's check. We know that first 1s. So first we have to write 1s. Then which one is there? 1s, 1s, 2s. So the order will be 1s, 2s, then 1s, 2s, 2p, 1s, 2s, 2p, then 1s, 2s, 2p, 3s, 3p, 4s, like that. P, 3s, 3s, 3p, 3p, 4s, 3d. Okay, so this way we have to write. So you have to study this electronic configuration by this method. You have to remember this. So it is very important. So what we can do? How can we fill? We know that in S subshell it can only carry 2 electrons. In P it is 6. D it is 10. F it is 14. So one S can accommodate only 2 electrons. So 1s2, 2s2, we know that in P6, so 2p6, 3s2, 3p6, 4s2, 3d10. This is the way of arranging electrons. So let's check with an example. So iodine's atomic number is 53, or else we'll start with a small element. Else we'll start with a very small lithium. Atom number is 3. So how can we write that? So we know that first we have to fill 1s, then 2s, then 2p and all. So lithium, 3 electrons are there. We'll start. Okay. So first 1s, how many electrons? 2. Lithium having 3 electrons, so it is 2. So how many electrons are left here? So 2 electrons are arranged in 1s. So 3 minus 2, one more electron is there. So 1s2. The next one is 2s. So this left out one electron will arrange in here. So the configuration will be 1s2, 2s1. And this 1s2, do you know which element having the electronic configuration 1s2? That is helium. Helium's atomic number is 2. So we can write the configuration of helium as 1s2. So here also 1s2 and here also 1s2. So we can write, instead of this 1s2, we can write helium. For instead of writing 1s2, we can write the nearest noble gas configuration. Helium 2s1. So this will be the configuration of lithium. This is the method. Okay. Then what about calcium? Calcium 20. So how can we write that? So 1s2. So you have to remember that order. 1s2, 2s2. So 4. 20 minus 4, 16. So we have to arrange the 16 elements. 2p6. Then 3s2. So how many electrons are arranged? 2 plus 2, 4. 4 plus 10, 12. So 8 more electrons are there. So 3p6. So 2 plus 4, 10, 12, 18. 18 electrons are arranged. So after 3p, it is not 3d, it is 4s. According to the rule, it is 4s. So 4s2. So this is the calcium. And here you can see iodine's configuration. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. After 4s only 3d comes, then 4ps, 5s2, 4d10, 5p5. We have to arrange the electrons in the increasing order of energy level. Okay. Here you can see another example. What are the rules? That is, we have studied it already. That is Aufbau principle. This is the building principle of electrons. First principle is the electron should be arranged in the increasing order of energy level. Then Pauli's exclusion principle, in an orbital, no two electrons having this both for an orbital may be occupied only maximum of 2 electrons. In an orbital, we can accommodate only 2 electrons. And sublevels are given, the how many numbers of electrons are in each sublevel. You can see here in S2, P6, D10, Hund's rule. First, in each energy level, we have to occupy single electrons, then only pairing will occur. You can see that nitrogen's atomic number is 7, so we can